Sound check, sound check.
Hello, hello.
Hello, Eli. Hello, Alerios. Welcome, everyone, to
Hey
this
guys.
Volter Bitcoin demos number 2. Hyped and very happy to have you guys here.
Let me check if we are actually live.
Yes,
Let's get confirmation 1 second.
we're gonna give it a minute or two to folks to join on X or YouTube streaming, whatever is your favorite platform. If you did not join us on X or YouTube, no worries, because these live streams are recorded, so you can revisit all the amazing concepts and deep dives, the deep technical dives that this series it's focused on. We had our first Volter Bitcoin demo series last week with a nice turn up. And yeah, we got also some questions about everything we are building. Today we have a special guest and a speaker. With us is Eli from the Leap Protocol. So we're going to start in a minute or two, guys. So we give a little bit more of time for those that want to join us live. And we'll start with some quick intros.
Yeah, let me bring the slides 1 second.
Amazing.
Okay.
We also had a technical overview of Volter Bitcoin this morning with the Core DAO community. Thanks again to Bim from the Core DAO community. In case you have joined, we had an AMA call on Discord. Lots of great questions about Volter, about Vol Layer, and again, we welcome everyone to do this, to join us on this Volter Bitcoin demo series, because these are more technical. We want to show what makes a Vol Layer and VaulterBTC possible. And I think we can get started, guys. Okay, so before we go through the slides, Eli, you want to do a quick intro and tell us a little bit about yourself, a little bit about Leap Protocol?
Definitely. Hey, everyone. Excited to be here. I'm Eli. I'm Chief of Staff at Lit Protocol. Have been here almost 3 years now. June will be 3 years. So it's been a long time. Previously, I was working as head of communications at the Oregon Blockchain Group, and then doing some more or less freelance kind of research, writing, contributing to some projects across the Web3 space. But the bulk of my Web3 career, if you want to call it that, has been spent at Lit. So I guess to speak a little more to Lit Protocol, what we're working on, what Lit is. Functionally, what we've built is a programmable and decentralized key management network. Lit it's a threshold MPC based system running inside of trusted execution environments. So you kind of have multi-level, or I guess multi layers of security. You have the threshold nature of the network itself, which requires participation from more than 2/3 of the nodes in the network to perform a given operation. And then again, additionally, all of these operations are taking place inside of trusted execution environments. So it's completely confidential, and it's node operators themselves don't have access, or end users don't have access to any of that data that's being processed. Now, what can you actually leverage the Lit network for? Primarily 3 services: signing, encryption, and compute. And so you have the ability to spin up key pairs. Again, these keys are distributed across the decentralized network, and then you can assign arbitrary logic to these keys using more or less Lit's version of smart contracts. They're called Lit actions, and they allow you to basically say, hey, when I meet the required permissions, or when these specific conditions are met, or again, when the price of this asset hits this threshold, automatically go and generate a signature or perform decryption or send this transaction to this chain and use it to trigger this functionality in this ecosystem. So it's very generalizable, fully programmable, and again, you can primarily use it to sign data, sign transactions, create wallets, perform data encryption, and then and kind of orchestrate and chain together some of these actions to create more complex workflows.
Amazing. Basically, leveraging everything we're building on Vault Layer and VaulterBTC. So thanks, Eli, for that overview. And we'll double down and zoom into some of the things you just mentioned a little bit later. So, okay, let's get to it. First, as always, everything we're showing today and sharing with the audience is for demo purposes. This is not financial advice. Guys, always do your own research. We love to share all of this with you, but DYR and NFA. All right. So when it comes to AI agents, the first question that comes to mind, it's how to safely trust an AI agent with our funds. As we all know very well, AI might hallucinate, developers could rug pull, and one user wallet per agent is just not scalable. So we at Vault Layer solve this by delegating a smart vault to Vaulter Bitcoin with on-chain verifiable policies. Later on, we're going to check that because today's objective is to show you how you can verify this yourself. Do not trust, always verify, and you can do this on your own. So this is the agenda. We're going to check how Lit Protocol enables secure decentralized signing via PKPs and lit actions, as Eli was mentioning earlier. Next, we are going to check and see how Vaulter uses custom policy contracts to prevent rug pull, how that was accomplished. And finally, guys, we're going to jump into a live demo. You're basically going to delegate Bitcoin to a smart vault agent, and we're going to check the process to not only that, but the different actions that you delegate, how you can securely verify that on chain. So let's start with a quick recap. And we talked about this on our first live stream, but it's always good to revisit some concept. So what's a smart vault? Smart vaults can be think of as decentralized wallets. In our case, these decentralized wallets are powered and made possible by the Lit Protocol decentralized key network. The second feature, a very important one actually, of smart vaults is that they are liquid. What does liquidity mean in this context? That they are tradable as NFTs. Those assets that a smart vault hold, that Bitcoin, since it's unlocked from an NFT, you can trade your NFT, your smart vault, and get some liquidity if, for example, you're doing some staking of Bitcoin on layer one on, let's say, Core. So that's the options that smart vaults open for users. You can trade, lend, borrow against your Bitcoin stake position. Or, as the third item expresses here, you can delegate your smart vault to an AI agent to aggregate rewards, execute swap, and do a lot of automation while you're doing your favorite thing away from your screen, away from keyboard. Okay, and how is all this possible? How all of this works? So first, users can go to Vault Layer, you mint a smart vault as an NFT, and you deposit Bitcoin. You deposit some assets. Very important, as Eli mentioned, no single node third party knows the full private key. With this access to the smart vault, that it's a decentralized wallet on the Lit Key network. And then we go to the third step, which is basically execute a specific action from the vault where only user-approved transactions can be signed and execute right there on the lit key network. And
Yeah, so we usually explain it high level like this, but now that we have Eli here, maybe we can dig a little bit deeper. So Eli, could you explain how these key shares are, like how is lead generating managing these keys? How does it work in reality?
Yeah, definitely. So there's a few different components to touch on here, but the primary kind of enabler of these decentralized keys is a process called distributed key generation, DKG for short. So basically, all of the nodes in our network come together, and they collectively generate these threshold keys where no single node ever has access to the entire key pair. They just hold a share of it. And collectively, again, more than a threshold of these nodes, so 2/3 of the network. It's currently a 10 node network, so that would be 7 of the 10 nodes. Those nodes have to come together in order to perform a given operation, such as signing a transaction. And so, again, to kick off the process, the DKG is run. This generates keys that are distributed across the entire network. And then when a given user or a user or a developer or whatever party wants to generate a key, they assign what we refer to as an authentication method to that key pair, which is basically like a credential that says, "Hey, this proves that I'm a valid party. I'm verified. I'm able to use this key." And these permissions are stored in a smart contract on Lit's on the Lit rollup. And so there's a dedicated L3 that's being run behind the scenes, which is more or less a shared state layer that all of the Lit nodes can use as a reference point. And so again, going through the full workflow, when I go and create a key on the network, I'm assigning a specific credential that then gets referenced on chain in a smart contract. And then when I go to use that key, all of the nodes are checking the chain and they're saying, "Hey, is this user permitted to use this key? Yes or no?" And if they are, then they'll provision one of their key shares. And then once the user collects more than 2/3 of these shares, they're able to combine them client side and use them to execute a given operation. Now, importantly, when those key shares are sent down to the client, they're done in a way that, again, even if the user were to collect more than 2/3 of those shares, they can't use those to actually recombine and create or form the key itself. So again, the key never exists and it stays secure. And then periodically, every 1 hour, there's which is the epoch length for the Lit network, those key shares are refreshed and rotated among the operator set. And so again, basically, they're incompatible. The old shares would be incompatible. So just another layer of security there. But yeah, functionally, as far as the authentication methods go, you can use a wallet or a Google account or SMS, emails, passkeys. Functionally, whatever credential or method you want to assign to these keys can be done. And then again, you can kind of chain together some of these permissions as well. But going back to the initial creation step, it's really the DKG, the distributed key generation process that makes all of this possible.
Amazing. Yeah, no, I think that makes it very clear how the keys are generated and how the distributed key and the shares are managed by the nodes. And I also like that you introduced the concept of the authentication method, which is, in our case, it is the NFT, but in other use cases of the lead network, there's other authentication methods. I think that's very cool that you explained how these authentication methods are used to give permission to use the distributed keys. I think the other interesting thing here, to maybe you can tell us more about, is like the DEE and the lead actions. So once the user presents a valid authentication method to the nodes, and they say, "Okay, yeah, this user can sign with this programmable key," how does that translate in the execution of the lead actions? Like, how can we know that these lead actions are being done as intended?
Yeah, definitely. Great question. So the key itself is definitely, again, you kind of have two components. You have the decentralized keys, and then you have the ability to program logic for how those keys are used. And so that's really where lit actions come in. Lit actions are essentially you can think of them as serverless functions that get run inside of the TEE inside of each lit node. And so again, it's the same. You do have the ability to run lit actions on a single node for specific use cases. We can dive into some of that later, but typically lit actions will inherit the same threshold properties as the rest of the network. And so when you write an action, it gets executed across every node in parallel. And then again, it's the same kind of threshold consensus that is used to verify that a given condition is met, or again, that a given operation should be performed. And so essentially, you can, whatever lit actions are written in JavaScript. So whatever you can write in JavaScript, you can execute and program in the lit network. And so you can use lit actions to create different permissions for lit keys, assign different authentication methods, or define like complex workflows. And so an example of a workflow would be what we refer to as a conditional signature. And so you could say, hey, I'm going to listen to this specific API endpoint that is reading the price of Bitcoin. When the price of Bitcoin hits 110K, I want to automatically trigger a sell order on this decentralized exchange using my Bitcoin holdings and swap it to USDC. And so the lit network, again, you would program that logic into the lit action. The lit network would there's an event listener solution you can hook up. The network would listen for that event to be emitted. In this case, they would be listening to it would be taking in the price data from the API endpoint. And then when that condition was met, the nodes would trigger a transaction on whatever chain that was configured in that action. So again, you can essentially write any logic that involves any on-chain protocol, off-chain protocol. Again, you can listen to arbitrary data from like the X API or e-commerce site or a TradFi account. It's really limitless. And then you can additionally kind of chain together some of these different actions and create, as I referenced before, create more complex workflows that maybe reference many different data points. And so, at the end of the day, the programmable nature of the network comes from the ability to write and define these actions that should be that give the keys power to be used on behalf of users based on the specific conditions they set. And then we'll dive into this a little bit later, but we basically released a framework on top of the lit network that is specifically designed to facilitate secure interactions between users and AI agents. And so again, as we kind of move into the AI era, where I think the thesis that a lot of us are operating under is that agents in a couple of years, or maybe a couple of months at the speed at which things are moving, agents will kind of dictate and manage a lot of our interactions online, whether it's on chain or off chain. And so we've kind of been working on creating some dedicated tooling to support these agent to agent and agent to user interactions in a secure and verifiable way, which we'll touch on a little later. But that's more or less how the lit action piece fits into the fold with the programmable keys.
Awesome. Yeah, no, thanks a lot for the detailed explanation. And when we started working with the LEAP protocol, we realized how powerful this is, because really all these years crypto has evolved around a lot of protocols and standards, but there was not an easy way to program signing and program cryptography. And I think that's where LEAD really came with this innovation of, okay, let's make signing programmable, and let's bring decentralization to the signing process itself, so I don't have to, continuously manage my seed phrases and have these other strategies like off-chain, cold wallets stuff. Like, how can I actually do that in a secure, programmable way in a network, right? So I think lead is very powerful with that, and lead actions also very powerful. But when we designed the smart balls on top of lead, we have been thinking on, okay, this is very powerful, but maybe it could be too powerful, right? Because we are delegating the signing of our keys to basically serverless action, or as we call it, like a JavaScript smart contracts. So how can we restrict that, right? So I think that's where our smart bolts, you could define them as restricted lead PKPs, because we use the power, but we try to uh, define just the right amount of lead actions that we want to be able to use. So our smart vaults are first authenticated with an NFT ownership. So if you are the owner of an NFT, you can, or you're the only one who can call and sign lead actions to uh, that sign and send transactions. And we specifically restricted it to 4 actions that we think is just enough for most of our use cases. So one is for signing arbitrary EVM contract transactions, another for Bitcoin transactions, including staking Bitcoin and redeeming Bitcoin on CoreDAO. We have one for decrypting secrets, and this is important, as we're going to see, for the Volter AI agent, because we want to share some data with the agents, but we want it to be encrypted. And the other important piece is how to delegate this signing to another party, in this case, the Volter agent. So these are the 4 lead actions that our smart vaults can do, and they are restricted to only these 4 actions, but it's flexible enough so that the user can uh, uh, define the policies for each of these tools. So if you're going to send a Bitcoin transaction, you can set policies to, okay, to who, to which addresses, with amounts, max amounts, etc. So these are very configurable. And we want to actually show. So we discussed with Eli all the theory, okay, and now we want to actually show how you can create one of these smart vaults. How can you actually verify which are the authentication methods that are permitted, what lead actions, what are those actions, like what is the actual code, etc. So let's go right into it. Um, we just go here. Let me also maximize the sharing window in the live stream.
That's better.
Okay. So what do we have here? We have Vault layer. So when you come to Vault layer, here I already have some smart vaults already created, and these are the NFTs. I have, you see here some NFTs that are the key to unlock my programmable key. So I can, mint a new smart vault, or if I already have one smart vault, I can go and check the details. So, for example, here I have one. Sorry, I have a little sore throat. Um, it's taking a moment. Okay, so this is a smart vault that I have minted, right? And what I get is, under the hood, a programmable leak key. We here have the link. And once this smart vault is created, I automatically get an EVM address, And we are also creating a derivated Bitcoin address. So this smart vault can hold Bitcoin and EVM assets on any chain actually. And we can do a bunch of stuff. We have done some deep dives into how to stake Bitcoin, get rewards in the core chain. We did a full live stream previously to show that. But now we're going to focus on, okay, how can I verify that this smart vault that we created here um, is actually secure and only my NFT can trigger these transactions, right? So we provide here the link to the lead explorer that is going to show us the actual public key of the lead key that was created for this smart vault. So we lead has this nice explorer where we can see the details. We can see that this public key pulls this public key Ethereum address. If I go here and I um, switch from the switch to the data network, which is our production network, we can see for this programmable key uh, these properties: the token ID, public key, and the same Ethereum address. This that was that we can see here. So this should be the
Mhm.
same. So that's the first thing you want to check. You want to check that this is the actual same uh, key generated for our NFT. Okay, so we can then copy this programmable key token ID, and we can go to the lead Yellowstone chain explorer. Here we are checking the permissions of the PKPs. This is a PKP permissions contract, and here we can see which authentication methods are actually permitted for this um, promo key. So wait a second. What's going
Yeah.
on here? Maybe I have to connect my wallet.
Yeah, it says well disconnected.
Yeah, it gets so slow when I on um, the live stream.
Yeah, this
Sorry
live
about
stream
that.
is it's heavy.
Okay, so I want to see the methods in this contract. Real write with proxy. Yeah, sorry. So this is a proxy contract. I was clicking here. Okay, so the PKP permissions contract. What can I see here? I can see a bunch of stuff. I can see which permitted actions, what is the Ethereum address. So we just copied the token ID. We're going to double check here. It's the same, exactly same address. And we get the permitted out methods. So let's see the permitted out methods. Basically, what we get here is, okay, this PKP has these authentication methods enabled. But how can we read this? Well, we know that it has each authentication method has a type, has an ID, and like we discussed before, there are many different types of authentication methods for each uh, programmable key. And in order to, decode this, it could be a little bit hard. So we created a tool that we are sharing here in our uh, Volter tool repository. It's fully open source. You can just go through this tool, and in this tool, we're going to do exactly the same. We're going to go to the lead contract permission contracts, which we are seeing there. We're going to get the authentication methods, and we're going to print them in a easy way. So let me just do that. And we are checking the smart vault with ID 9. So I'm going to run here the script, and it's going to just show us that this smart vault, this same ID that we have here, which should be the same that we are showing in our um, UI here, this one here, it says, okay, this has this token ID that we were seeing also in the Explorer, the public key, the same address, and it has this um, IPFS lead actions identifier. So what is IPFS? For those who don't know, it stands for Interplanetary File System, and it's just a decentralized storage network where you can store multiple things. And once they are stored and once they have this identifier, they are basically set forever. So um, each of these IDs are identified a lead action that we are going to run with this PKP. So we can see here that we have these four. They correspond to what we expect: the coin transfer, call an EVM contract, sign Bitcoin transactions, decrypting, and our identifier for our smart vaults. So uh, this is all looking good, but how can we know that this is actually the code that we want this PKP to run? Okay, so one last step that you want to do if you're verifying all of this by yourself is you can go back to the Lead Explorer. They included some nice also IPFS function visualization here. So if I put that IPFS here, this is JavaScript code. You can see this is the JavaScript for the lead action, and it's on the IPFS network. So this is a bit cryptic because it's the JavaScript code. If I look for ERCs and 21, 7, 21. So here's like the vault layer specific code. So again, this is like compiled JavaScript, but we also include the same code. It's also in our repository. So for example, for that tool, we can come here and check the actual call contract lead actions tool. This is the exact same code here. So for example, okay, let me see which one was the tool that I was checking. Checking the coin transfer tool, call contract tool. Let's check the sign PV, third one, this one. And let me know if you're a bit lost. Juan, Eli, how are we doing? Are you following me? We're going step by step.
Yeah, I think you're doing a great job at the step by step, starting with the Vault ID that will take us to the Yellowstone Explorer on Lit. And then, of course, how can we check the IPFS IDs, whether through the Lit Explorer that provides us also when we provide an IPFS ID with a way to get that JavaScript decoded and check specifically the lit actions that are set in there, immutable. So yeah, I think just it will be a matter of just rewind if we want to be strict and do the exact step by step. But I don't know, Eli, what do you think? I mean, of course you're well versed on lit, but on Vault layer's approach to lit actions and how the way we have restricted them.
Yeah, no, definitely. I mean, I'm happy to speak a little bit to kind of the underlying architecture here and what's going on under the hood, if that would be helpful, or I can also kind of summarize some of this after the demo if we want to continue. Whatever you guys think would be best for the audience here.
Yeah, no, I think we covered, how can people actually verify all this? I mean, if we go back uh, to here, so we just went through all these steps. We figure out what is the PKP public key token ID. We checked which are the lead actions that are permitted, and we directly on the lead contracts. And we also check the immutable code on IPFS. And we also use our script to actually verify that those are the things for the BKP. So I think we covered this in detail. Um, Maybe we can talk a bit more. Okay, so this is how the PKPs are authenticated and they can trigger some tools. Okay, so now maybe we can move forward. How do we use these for delegating to an AI agent, right? So, and this is just a graph that we have to show that once you have the control from your entity to the smart vault, you can then delegate uh, the signing of those lead actions to an agent, and that is being done on some contracts. Um, and we are using the same kind of framework by the Vincent lead contracts. We did a few tweaks ourselves, but basically it's the same Vincent contracts. And once we do that, we can delegate to the agent, and the agent will execute exactly what we do. So maybe, yeah, can you tell us more about how it all comes together, and like why did you create Vincent? That was the approach.
Yeah, 100%. So I guess backing up a little bit, the initial question or kind of prompt we were looking to solve when we created Vincent was how do we trust a AI agent with our most sensitive funds and data and assets? How do we actually trust and how do we verify that the conditions or the actions or operations that we want the agent to perform are actually what it's going to do, and it's not going to hallucinate, or there's not a developer behind the scenes that's secretly rugging the user or would have the ability to rug the user. So it's like we're trying to create these verifiable guardrails for facilitating, again, these secure user to agent or agent to agent or agent to user interactions. And so what we built, which is more or less a abstraction on top of the PKP and lit action and the other kind of core network infrastructure, all of those components that we introduced earlier. This Vincent framework more or less wraps all of that, and it makes it easier for developers to create these custom workflows for their users, and it makes it and it gives users the ability to kind of consent to and fine grain their permissions as they see fit. And so Vincent, again, more or less provides these verifiable guardrails for delegating actions to or operations to third parties to perform on behalf of a user. In this case, the third party being an AI agent. And so how does this actually work under the hood? There's two kind of core components here, or I guess three core components here. One is the user and agent's account, which is represented by a PKP, a key on the lit network. And then there are tools and policies. And so both tools and policies are represented again by these by lit actions, these programs that you can write that again are executed on the lit network. Taking them one by one. Tools more or less give the agent the ability to perform a given operation. So for example, a tool could be the ability to perform a swap on Uniswap. And then a policy would set the parameters for how a given tool is executed. And so it could be like a spend limit for the swap, or specific allow listed token addresses, or a combination of any of those factors. So again, a tool defines an operation that an agent can perform, and the policy sets the parameters for how that operation is executed. And so the Vincent framework, again, provides developers an easy way to create these tools and then expose different policy variables to end users. And then the end user has the ability to fine grain and consent to these different tools and policies as they see fit. So again, imagine interacting with a trading app where the app would you'd be presented with a consent screen, and you could be like, okay, the agent can trade up to $50 of Ethereum on base and L1 on under this specific time frame, et cetera, et cetera. So again, the user would have the ability to kind of tailor that and tweak that as they see fit. And then ultimately, how is any of this trusted or verified? So the policies or excuse me, the tools are all referenced, the IPFS CIDs where the lit action tools are deployed. Those are referenced in a smart contract on chain. And so you can basically verify when you're interacting with a given Vincent app that the tools are legit. They're again posted to chain, they're verifiable. And then again, when a given tool is executed, you inherit the threshold nature of the lit network, where again, each node is executing that tool in parallel. And then again, similarly, when a given policy is checked, the nodes are verifying that it's met, and then executing their share of the transaction before it's passed on to the next node. So again, this whole framework ultimately just makes it easier for developers to kind of build these apps and specifically create these agent-led workflows. And then on the user side, they have full control over kind of how these different actions are permitted and specific the ability to kind of fine grain these policies as they see fit. And then again, it's all verified on chain or verifiable on chain, and inherits the TE nature or the TE execution inside of each node, and then the threshold nature of the network and where the keys and data is managed as well.
Awesome. That's a powerful explanation and powerful tools. I mean, when we also saw the Vincent framework by Lit, we say, yeah, I mean, this is a great approach. It's also very powerful. So we say, okay, we can use these to create our agent and define the policies on top of it. So we started using in Vaulter. We did also, realize that it's so powerful that we also wanted to kind of restrict it a little bit for just our use case, like any other developers can do with the general Lit tools. And we came up with some specifics. So let me show you how we are using the Lit. Give me 1 second. Let me show this other screen. Okay, so I think this goes together with what you were saying, Eli. So we are seeing at an instance of the Vincent contracts that we created for Vaulter. These are some of the applications that we have created. We created one just for the setting the strategy, but we have these, which is the actual permissions that we are giving Vaulter when we delegate to it. And we can see here that what we are doing when we execute the delegation of Vaulter, we are triggering this on-chain, an on-chain transaction that is going to give permissions for these tools. So we see here the same tools that we we're checking before that are assigned for our PKP. Now we are delegating them to Vaulter. So here, so for example, we have the call a contract, sign Bitcoin transactions, sending coin transfers, decrypting. And what we are setting here is not just calling the tool, not just delegating the tool to the address of the agent, which is here shown as the delegates, but we are also setting some policies. So the policy itself is another IPFS code, and it's where we define those limits. For example, for the call contract tool, we are defining the max value, like what contracts, what functions, or on what chains we want to delegate. The same for the Bitcoin transactions. We are giving a list of the Bitcoin addresses that we are going to let Vaulter send Bitcoin to. The same with the coins And for the decryption of the secrets, we are giving some prefixes that this agent will have access to decrypt. So these kind of tools that we are delegating are the ones that we see. So let's see it in action. Let me switch to the agent. So going back to Vault Layer app, we just minted this smart vault. We can, deposit assets here, and when we delegate to Volter, this is going to, let's take it a while. Why is it taking so long? Am I? Let me switch to beta. Beta layer. Dangerous demo. Dangerous live demo on localhost. Don't do that. Okay, I'm in beta. Okay, this should work better.
Yes, while it loads the smart vaults. So Eli, how long has been Lit working on this? Is it 4 years, I think, on all this amazing
Yeah,
technology?
yeah.
4 years, right?
Coming on 4 years here from since the very beginning. There have been numerous kind of initially we were very much focused just on the access control encryption side of things, and then in the fall of 2022, we started rolling out some of the signing and lit action functionality in beta, and then last year in 2024, we released our first decentralized mainnet beta, which included the encryption stuff and the signing and lit action features, all of that in production. And then back in August of last year, we released our second. It was the second mainnet beta release, which had some performance improvements and a few feature upgrades from that initial release, and a few key bug fixes as well. And then that's been running since August, and we're currently working our way towards our V1 mainnet launch and TGE. And so that's currently slated for this summer, looking at July right now. But yeah, it's been a long journey, and we're very excited to finally, as we like to say, finally get to the starting line here.
Yeah, amazing journey. Amazing. Back to you, Alejandro.
Yeah, very exciting. So yeah, I was just coming back to, okay, how does this look in an actual use case? So in our own use case, we have the smart vaults. We can load assets into the smart vault. Like we said before, we can do Bitcoin staking. We can do core staking. We can do a lot kind of things. But as a user, I don't really want to come here and claim my pending Bitcoin staking rewards like every day and then swap and I'll do all these things. So instead, I want to delegate this to an agent so that it does it for me. And what it's doing here is decrypting and going to these Volter policy contracts to retrieve my current strategy. So I have my Telegram here, and we are showing here like this because it is being encrypted, also using lit, and it's only going to be visible for the agent. I can set the connection to my Volter agent, and this is just like the first time we create this link between the Telegram bot and your wallet, just because we didn't want to create another chat application. We know users are already in Telegram, so we say, okay, let's use Telegram as the chat interface. Let's not create yet another chat interface, because we don't want to create a wallet with a chat. We want just set policies and then get a report back from the agent. Or if I want to talk to the agent, I just use the existing chat application that I already have. So when you click here, you just start the conversation with the agent. Um, we can set some policies here, and basically what we are setting here is just like a initial template for the prompts that the agent is going to run. So we have some sample strategies. Right now, we are focusing on just growing the Bitcoin staking rewards. For example, I can uh, tell the agent to every day swap my Bitcoin staking rewards BLT core to USDC. Or maybe I can load it with USDC and I can tell it, okay, every day buy more Bitcoin. Right now we have red Bitcoin, but we're also going to provide a direct tool for swapping directly from and getting the actual Bitcoin. So all these strategies are just a set of tools and actions. Here we can see like the detail. When we select one of these, we are just instructing the agent to use some of the tools. So right now we have a swap tool and the fetch balance tool, query swap history. So this is like the set of tools that the agent already has, and we are just instructing it to use those tools in a prompt. We can also customize the prompt. Like for example, I always use like always call me boss. Here, for example, warn me, make our balances below 0.05, and I can give this amount, and this is starting to tie together with the uh, specific policy values, like what tokens, what contracts, what amounts I want this to be able to do on myself. Like Eli was saying, like under the hood, this is going to write on those policy contracts, and maybe you can also delegate this to some other agents, and you're going to give consent to those other agents. But right now, we are to make things easier. We just developed this delegation tool right embedded in our app. Um, so once I confirm delegation here, it's going to go to that contract that we were seeing here, and it's going to generate the transactions to delegate with my parameters to this and to the strategy definition. We see the strategy definition. It has those parameters like the strategy type, the custom prompt, the secrets. So here I get two transactions, one for each of those apps that we are delegating to the Volter wallet. So if we explore, those settings are being done to the same contract address that we are seeing here. This is not, oh yeah, this is the local host one. Sorry. Okay, never mind. So that should be to the same kind of contract that is deployed. In the Telegram, what we see when we get the confirmation from these transactions is, okay, Alejandro, your delegate strategy were updated for this vault, and we are good to go. So every day, like you see here, every day, the past few days, which I've been having this strategy enabled, you see that every day at 11 p.m. my time, 11:30, it says, okay, I'm going to start the execution. It starts by claiming the rewards and then swapping as I instructed it. And it shows me the summary and creates a report, etc. All of this. So the next day, the same time, 11:35 p.m., I also get the same, like it's doing what I delegated it to do, and it's just giving me the report. And I can, be getting mojitos on the beach while he does all of this. For the demo, we set it to do it in 1 minute from now. So now here it's going to start executing this strategy that we set here. So it already started. It should swap swap USDC, swap 0.05 USDC to BLT core. Okay, so it takes some time. I could also, anytime I want, I can also talk to it. I mean, I just setting the strategy for daily activation is not the only way. I can also come here and directly instruct it to do some more things. We can see here that it did the swap over 0.5 USDC. This is all like the swap history, and it was all, autonomous. And I can also say trigger like a new one here, or I can also talk with it here on demand. So that's it. Questions, comments, Eli? One.
Great overview, Alejandro, and great demo on what is possible when you delegate your smart vault to Vaulter. Uh, Definitely, we are very excited about what's to come. As Eli was mentioning before when giving us that overview about Vincent, the quest is for finding the best, more secure solution to do that, delegation of assets to agents as secure as possible. And I think Lit and the Vincent framework are going to great lengths to get us there. So that makes all this possible for builders such as us at Vault. So yeah, I don't know, Eli, if you have some last remarks. I think we have a couple of minutes left.
I guess just first and foremost, no, this is a really, really awesome demo. And again, functionally what's possible here is limitless. And so this is a really exciting example of the sorts of applications and kind of workflows you can build. And we can't wait to continue expanding upon these use cases, and again, kind of eventually having this ecosystem of applications that more or less are leveraging data from one another. And again, it's all user driven. Users remain in full control. It's all verifiable. It's all on chain. So yeah, we're super stoked to get this out there. We'll be releasing several new updates to the Vincent framework here. Target is at the start of next week. Some of this will include a new tool registry and SDK, which will make building these tools and discovering new tools much easier and simpler for builders. And then we'll have some new features for users as well, in managing some of these, managing some of these policies and tools much more intuitive and exciting as well. So we're stoked about that. Very grateful to be working with the Vault Layer team, and super impressed with all of the great work they've been doing. And yeah, they're one of the first teams to kind of get some of these workflows deployed using that framework. So it's been a real pleasure working with them. And yeah, thank you for having me on. It's been awesome getting to chat with all of you today. And yeah, super excited for what's ahead. If you guys want to stay updated, go ahead and give Lit Protocol a follow here on X. And otherwise, yeah, we'll have some new updates to share very soon.
Amazing. Thank you, Eli, for those words. And yeah, looking forward to it. Guys, I think the quest for Lit Protocol CG are still going. Am I correct? So also go and take advantage of that and stay tuned. We are doubling down on this series of demos. We wanted them to be as educational as possible, going into this technical deep dives. So stay tuned for the next Vaulter Bitcoin demo series next week on Thursday, and subject yet to be confirmed, but stay tuned for the topic. And yeah, thank you, everyone.
Awesome.
Thanks, Eli. Thanks, Juan. Thanks, everyone, for your time.
Bye-bye.
Okay.
Have a good one. Bye.